In this video, we're going to talk about the graded membrane potential and the action membrane potential. So, the purpose of this video is to continue on what we have started in rest membrane potential. Remember that we talk about we said the rest membrane potential is the potential difference or the voltage when the cell is not transmitting any impulse. You understand? We have explained that, and we should have understand that. Now, remember that I mentioned something that we have something like this. We have the neuron, and in the neuron we have another neuron at the end of the neuron. And I said this space around this space is termed what? It is termed the synapse. So it is the space at which information is going to flow through from one neuron to another neuron. And I mentioned that instead of me studying the presynaptic neuron, this is presynaptic neuron. I'm studying the postsynaptic neuron, and there's a reason. The reason is because I want to move from the resting membrane to graded membrane to action membrane, instead of moving from resting membrane to action membrane, then still come back to graded membrane. So that's the reason why I want to study the postsynaptic neuron. And remember that I said in the postsynaptic neuron, the same thing that happens in the presynaptic neurons happen in this postsynaptic neuron. But I just want you to know that I'm talking about the postsynaptic neuron. The same thing happened in the both of them, so you don't need to convince yourself. Now remember that I said we are studying this for what? For the resting membrane potential. When it is not transmitting any impulse yet. When impulse has not flew from the presynaptic neuron to the postsynaptic neuron. Let's now take for example, this one has been stimulated. Impulse is flowing through the what? Through the axon, down the what? Down the axon hillock. From the axon hillock down the axon terminal rather. Sorry, I mean axon terminal. Down the axon terminal. Now it now want to flow. It now want to pass the information from the what? From the presynaptic to the postsynaptic neuron at this synapse. So it is this synapse that I want to study now. From this synapse to this what? To this cell body. Remember that the voltage of the cell body is what? Minus 70 millivolts in this case. It is minus 70 millivolts. Now, the question now is, what is the purpose of graded membrane potential? You see, the purpose of graded membrane potential is to take the cell membrane from resting membrane potential to threshold voltage. That is the function. And what is threshold voltage? This is the voltage that is required to open a voltage gated sodium channel in the axon. Remember that the axon is responsible for the what? For the flow of what? For the flow of impulse through the what? Through the nervous system. It is responsible for the flow of impulse. Now, if the axon is not stimulated, if the channels in the axon is not stimulated, the impulse won't be able to what? Information won't be able to flow through the nervous system. Now, threshold voltage is the voltage or voltage. It is the voltage that is required to open a voltage gated sodium channel in the what? In the axon. Are you getting me now? Now, how do we achieve threshold voltage? That is where we have the concept of what? Of graded membrane potential. So it is not something hard. We can just explain it the way we explain the other one as well. Now this is a cell membrane. This is a cell membrane. Still the same cell membrane. Still the same cell membrane. So we want to move it from minus 70 to around minus 55 millivolts. That is where we want to move it. Now, how do we move it? If you are asked to explain the mechanism, how do we move it from minus 7 to minus 55 millivolts? So this is what is going to happen. You see this stuff that I drew here, this stuff here, this one and this one, they are ion channels as well. I get me. They are ion channels. But these two ion channels, they perform different function based on the what? Based on the neurotransmitter that is being secreted. What are neurotransmitter? Neurotransmitter are chemicals that is being stimulated or that is being secreted by the presynaptic neuron to the postsynaptic neuron, either to influence the continuation of the impulse or to inhibit the flow of information, either to excitate the flow of information or to inhibit the flow of information. That is neurotransmitter. Are you getting me now? We now have different type of neurotransmitter. We have two. We have the excitatory neurotransmitter. Excitatory. Sorry, I have a very good handwriting. And the inhibitory neurotransmitter. inhibitory neurotransmitter. You see this excitatory neurotransmitter, it is the one that excites the flow of information from the presynaptic to the postsynaptic neuron. Which means in excitatory neurotransmitter, what it does is what? It takes the cell from the resting membrane potential, which is minus 70 millivolts, to threshold potential, which is minus 55 millivolts. Are you getting me now? Minus 55 millivolts. You now see this inhibitory is the one that inhibits. So what it does is that it takes the cell from minus 70 millivolts to minus 90 millivolts. And if minus 55 millivolts is not attained, impulse won't be able to flow through. You understand? So this one takes excitatory takes from the word excites. It's like it excites the cell. You understand? So that is it. Now, different type of neurotransmitter. I said excitatory neurotransmitter. Example is acetylcholine. The most common one is acetylcholine, ACH. In case you see ACH, acetylcholine. Another one that is an excitatory neurotransmitter is which one is that? I think glutamate. Yes, glutamate is an excitatory neurotransmitter. Glutamate is an excitatory neurotransmitter. I think is it epinephrine? Epinephrine is also an excitatory neurotransmitter. But inhibitory, example of inhibitory neurotransmitter is gamma. It is gamma aminobutyric acid. That is GABA. We call it GABA. GABA is an example of inhibitory neurotransmitter. Also, dopamine. Dopamine is an example. Glycine. Glycine is an example of inhibitory neurotransmitter. You understand? These are examples of inhibitory neurotransmitter. So let's not take for an example. We have a cell like this. We want to move it from minus 70. No, let us talk about the inhibitory first. So let us take for an example. The neurotransmitter that is being transferred from the presynaptic neuron to the postsynaptic neuron is now GABA. Let us take for an example. Remember I said GABA is what? GABA is inhibitory neurotransmitter. So let us say it is GABA. There is a pocket around this place. There is a pocket that closes the ion channel. You understand? So let's say it is GABA that is being transmitted. What GABA wants to do is that what? It wants to inhibit the passage of what? The passage of this thing. And it wants to take the cell from what? From minus 7 to minus 90 millivolts. What is it going to do? It is going to open the ion channel. I get me now. It is going to what? Open the ion channel. Once it opens the ion channel, it is going to allow the efflux or the flowing out of the what? Of the potassium ion. Remember that potassium ion always leave an ion behind. You understand? It always leaves what? An ion behind. So we are going to have many negative. As it is allowing the efflux of potassium ion, it is allowing the influx of chlorine ion. Are you getting me now? As potassium ion is flowing out, chlorine ion will be flowing in, making the cell to be more negative to minus 70 to around minus 90 millivolts. Are you getting me now? Because it is leaving an ion behind, making the cell to be negative. It is now allowing chlorine ion to flow inside, which is a negative ion, making the inside to be more negative. And this process of making something that is negative to be more negative is termed hyperpolarization. Hyperpolarization. It is polarized already. I get me now. Then you are now polarizing it more. I get me now. You are taking it from negative to more negative. That is hyperpolarization. Hence, the function of inhibitory neurotransmitter is to hyperpolarize the cell to prevent the passage of what? To prevent the passage of information through the what? Through the nerve and the neuron, through the axon. You understand? So it makes the cell to be more negative. It hyperpolarizes the cell. You understand? That is what it does. Now let's see for an example. It is not GABA that is being secreted. It is now acetylcholine. Let's say it is ACH that is being secreted. What does ACH do? What it does is that it opens the channel. It opens the ligand-gated ion channel. Once it opens the channel, it allows the influx of sodium ion. It allows the influx of sodium ion, and allow the influx of calcium ion as well. You understand? Allow the influx of sodium ion and calcium ion, making the inside of the cell to be what? To be more positive, taking it from minus 70 millivolts to around minus 55 millivolts. You understand? Now, Once minus 55 has been achieved, axon A-lock is stimulated to open the ion channel. You understand? I get me now. But what is to be noted in this place is that before graded or threshold voltage is being attained, there must be something we call summation. Now, I've not mentioned something. There's something I'm supposed to mention. IPSP, and let me mention it here. IPSP and EPSP. You see, IPSP means inhibitory post-synaptic potential, and EPSP means excitatory post-synaptic potential. You understand? Now, which means to attain the graded membrane potential, which is threshold voltage, we need EPSP. You understand? We must have EPSP, which is excitatory post-synaptic potential, and the excitatory post-synaptic potential is what? Minus 55 millivolts. So to attain minus 55 millivolts, we must open the we must have excitatory neurotransmitter, and the excitatory neurotransmitter is going to open the ion channel to influx of what? Influx of sodium ion and calcium ion to make the inside of the cell to be what? To be positive. You understand? Now, making something that is negative to be less negative is termed as depolarization. So that is depolarization. That one is gone. So we said, I mentioned something now. I mentioned summation. I get me now. Now remember that I said we have a cell like this, and we have a cell like this, which means this is the synapse. I'm trying to stimulate this particular. I have someone. Let me use an illustration. This is a house. Sorry, I'm using a house. This is a house, and this is me, a very tall man, and we have a very short girl inside like that. So I'm trying to enter the house. I am the I'm the presynaptic. I get me now. And this person inside is the postsynaptic. My short friend is the postsynaptic. I get me now. Now I'm trying to enter inside. What I'm going to do is that I'm going to knock. I get me now. If I knock once, now I knock the door. You understand? Now, if the person did not hear that I'm knocking the door, I will knock it again. If the person did not hear, I will knock it again. Until the person what? Until the person hears that I'm knocking the door. That is the first case that might happen. The second case is if we are more than one that is knocking the door, I'll be the first person to knock the door. Another person comes. You understand? We have another person. So let me say I have 3 friends with me. I knock the door. The person did not hear. This one comes, knock the door. The person did not hear. This one comes, knock the door. Until the person hears. You understand? Which means there are 2 cases. The first case is having one presynaptic neuron. And the second case is having more than one presynaptic neuron. You understand? That is trying to stimulate the same postsynaptic neuron. I get me now. So let us take for an example. So that case, it shows us that we are having what? Let us say this is a presynaptic neuron and this is the postsynaptic neuron. You understand? Now, the synapse, it's knock once. You understand? The second time, the third time, before axon lock is being stimulated. I get me now. Now, that one is known as temporal summation. Remember I said it is summation. I'm going to explain how it is summation. Temporal summation. I get me now. Now, how is it summation? What is happening is that this is a graph. This is the resting membrane potential minus 70. This is the minus 55 that I want to attain. I knock the first time. You understand? I knock the first time. I get me now. Let me. Now look at it. I knock the first time. It goes, but did not reach the threshold potential. What it's going to do is it's going to hold it. You understand? It tries to force down. I knock the second time. I get me now. It did not reach. Then I knock the first time. Then I reach the what? I reach the threshold voltage. You understand? So it is summing it. Summation of everything. When there is only one presynaptic neuron, it's termed what? It's termed temporal summation. Are you getting me now? Temporal summation. Now, how about the second one, where I'm having the first person, the second person, and the third person, trying to stimulate only one neuron. Now, I will still draw a graph. This is the rest membrane potential, 70, minus 70 rather. And this is the threshold voltage, minus 55. I get me now. Now look at it. This person knocked the first time, reaches this place. This person knocks, reaches this place. This person knocks, then it reaches the threshold potential. And this is known as the spatial summation. So we have type of summation. We have the temporal summation, and we have the what? And we have the spatial summation. I get me now. So the temporal summation happens when there is only one presynaptic neuron, and the spatial summation happens when there is only one postsynaptic neuron. Are you getting me now? So this is just the concept. You knock once. What I just want to do is I want to tell the person that is inside of the house that I am outside. Please open the door. Which means I want to open the sodium gated channel at the what? At the axon. So I'm trying to stimulate the axon lock. This is the neuron, sorry. This is the neuron. You see this place is known as axon lock. This length is known as axon. You see this axon lock? You cannot stimulate the axon. You cannot pass this thing through the axon without stimulating the axon lock, which means one of the most important parts of the neuron that's function in the transmission of impulse is axon lock. Very, very important. So everything I'm trying to do here, temporal summation, spatial summation, is to stimulate the axon lock. You understand? Everything is just to stimulate the axon lock. Just to stimulate the axon lock. So this is what I'm trying to do. So once axon lock has been stimulated, minus 55 millivolts has been attained, then action membrane potential can now what? Can now set in. You understand? So in the next video, what we are going to be explaining is what is the action membrane potential in the next video. Thank you so much for watching, and let us just do a little bit of revision. We have already mentioned the excitatory postsynaptic stuff. We said we have the presynaptic, we have the postsynaptic, and we said the space between this neuron is the synapse. We mentioned that we have two types of neurotransmitter. We have the excitatory neurotransmitter, we have the inhibitory neurotransmitter. Are you getting me now? So we said if the excitatory is secreted, it's going to take the cell from what? From minus 70 to minus 55. But if the inhibitory is secreted from minus 90 to minus 70 to minus 90, and from minus 70 to minus 55 is known as depolarization, from minus 70 to minus 90 is known as hyperpolarization. You understand? So that is just what we are talking about. And we say we have different types of summation to attain graded membrane potential. We have the IPSP, we have the temporal summation, and we have the spatial summation. So that is what we have said so far. Thank you so much for watching, and subscribe for more. Thank you.